Hi, my name is Stefanie. I'm a developer at ThoughtWorks, and this is my colleague Johannes. And today we're going to talk about offline web applications. And yeah, we actually brought you 2 case studies today, and one of them is the project Johannes and I are working on. Maybe a short notice, I'm really bad at talking with those microphones, so usually at one point I start pointing at the slides. So if that happens, please let me know, and don't let me look like a total retard. Yeah, that's our colleague Johannes, Lukas, and that was his face when our client came to us and said, we want to build an offline web application. So he's a developer as well, and as a developer, you usually think, oh my gosh, offline web application, stale data, merge conflicts, upgradability, and how do we even test this? So is this really a developer's nightmare? But we actually set out to explore some of the technologies that are out there, the HTML5 storage technologies, and we thought, maybe we don't want to be overly dramatic, and this is actually just a nice little challenge to solve. So, but before we started, we actually had to figure out, what does offline actually mean? Does offline only mean the little T-Rex in the Chrome browser, or is it more than that? For us, it was actually more than just no connectivity. It was also big latency and really poor connection. Imagine when you're going on a tube and you're just connected via GPRS. So for us, an offline web application meant all of this. And to go on, Johannes tells you a bit more about the history.
So we wanted to do a quick recap of what web application could do. And before we start, maybe a word of caution. Of course, we know that building offline applications is not something new. You were able to build offline applications with Java or with C++ way back in the days when you had like a Java application. What we're talking here is how to do it in the modern browsers, and that's the technologies we're actually showing to you. And if you look back, the web, not that long ago, the web consisted of very, very stupid web pages. You had HTML, you had maybe CSS, and the JavaScript was there to floating elements around, right? And all the logic was in the backend, and the backend was running PHP or some other weird technology. Yeah, and then a company came along called Adobe, and they created this term rich internet application, and you were supposed to write those stuff in Flash. So how many of you do rich internet application these days? So all of you are doing Flash, right? Okay, the term kind of stayed, the technology kind of didn't, except for video. But what does a rich internet application mean? It means you have still some static resources you need to pull from somewhere, like you might have some HTML, your JavaScript application these days, the CSS, and this you have to just pull it down somewhere onto the client. And then you will be typically talking to a REST-based interface to store the data with the server. So the question now is, when you have the possibility to store data in the browser, could you have an independent client? Of course, you can't have an independent client without ever being connected to the server, because you need to pull the data down. But then if the client remembers the data you pull down, it can execute the application. And also, if you have a local storage in some form in your browser, you can also be disconnected from the internet and allow the users to still work with your application, and maybe then sync the data with your REST API once connection becomes available.
So you might ask yourself, why would you want to build an offline web application? Why did a client came to us? And I was talking about the 2 case studies that we brought today. And the first one is done by our ThoughtWorks colleagues in the UK. It's about a big supermarket chain, Morrison, and they wanted to go from paper-based ordering to tablet-based ordering. So what they did before, they basically went through the stores with a big stack of paper, went through the different aisles and checked how many products are still there and how many they have to order. And they wanted to do that with a tablet, so they wanted to use commodity tablets, and they didn't want to decide on a technology yet, and so they decided to build an HTML5 application. And but you can imagine like the supermarket not being the best place to ensure a good Wi-Fi connection. First of all, the supermarkets are pretty big, so they have multiple routers, and when you go with your tablet through the different aisles, you'll lose connection at one point until you get connected to the next router. A second thing is that they also have a lot of metal shelves, which makes it hard to ensure a good Wi-Fi connection. And also, they have these big walk-in freezers, and they're pretty good at like keeping the cold in, but also keeping the Wi-Fi out. So that's why they wanted to have an offline web application. And the other client we're talking about is the project Johannes and I are working on. That's the traveling product tester. So our users, they build a lot of different products, all kind of products, and they usually do specify how the product should look. And then they go to the manufacturers abroad and take products from the sample lane. And then they check them, like make pictures of them and check if they still fit their specifications and do quality analysis of those products. So they need to have those documents ready at any time, and the factories cannot ensure Wi-Fi connection at all times. And maybe a nice side note is that our users actually need those specifications and all those documents related to the products anytime, and they need to be able to print them at any time, even when they have no connections. So they usually carry a little USB printer with them, and they like update their documents even when they're offline, and then they need to generate PDF documents out of them. So this is not part of this talk, but if you're interested and if you want to know how to generate PDFs in the browser with JavaScript, yeah, you can find us at the venue. We're happy to talk about this. It's another fun story. But now that you maybe have a background why we had to build offline web applications, we're going to answer how we approach these scenarios or these applications. So we basically tried to split this talk into three topics. First of all, how you get the client available offline, so kind of like how you download your web application. Then, of course, you need to get the data available offline. And third, you also need to handle data changes, like what if you have a sync conflict?
Yeah. So I start with getting the client offline available. I actually read something yesterday evening that sometimes you even have to make sure the third parties you embed in your website need to work offline, which is not that easy if you have a Facebook widget or something like that. But we're not talking about that because we don't have I have an idea how to do that. But I have an idea how to get your application to the client. So this is the situation you are in. You have all these bunch of clients, and clients these days are always laptops or even mobile devices. And then you have the server, and it has all this JavaScript, HTML, CSS. And you want the clients to remember them because they might not have the connection. So the easiest way you could think of is go for HTTP cache. And that works kind of well, because if you set the cache headers correctly, the browser remembers them for a certain amount of time, maybe. So you don't have a guarantee. You don't know if the browser is removing it at some point, or if the client uses a browsing mode which automatically deletes all the caches once he closes the browser. So if you want to be a bit more sure that the application stays there, there is a technology called app cache. And what app cache does is it provides a way to specify these are all the files which belong to my application. All the HTML, CSS, icons, JavaScript, everything I want to be stored, download it. And then the clients will download it. And yeah, at some point you update your application. So let's say we are on version 254. And some clients may get the new information because they are online at that point, others may not. And the interesting thing is now you have multiple versions of your applications out there running. So be prepared that users will have different versions when they call you and say something is not working. So how would you do that? I'm showing a little bit of code, although it's not too much. So in the basic HTML page you want to have cached in. You just specify something called a manifest. In this case, you call it upcache manifest. And this is a flat file, and it looks like this. It starts with the simple words cache manifest. And then you list all the files you want to be stored in this application cache. So in this case, I have like an HTML file, an icon file, a script file, everything you need. And now comes the tricky part. The application cache assumes when you specify the files in here that everything of this application is in this cache section. If you want to have a network connection, because if network is there, you want to maybe call an API, you need to whitelist it. And the best way to whitelist this is just doing a star here. Because everything which you don't whitelist, the app cache will assume, yeah, well, it should be here or it's not there. So if you have a link to www.google.com on your website and you haven't done this star or haven't explicitly whitelisted Google here, it will try to serve it out of the application cache. And the files listed here will always be more important than what you see here. So always do a star there and you're safe, basically. For everything which should be available on the network, you can also specify a fallback. So here, the fallback is for everything under the local domain, and this will go to a page which could say the user, well, you are not connected to the internet, so this functionality doesn't work at the moment. Your browser will determine if there was an update to your application by the contents of this very file. But the trouble is, most of the time, when you do good practices, you won't change the file names in this file. So you will compile all your JavaScript into this script.js file, for instance. So even when you do a change, the file won't change. So you will typically have a hash or a date stamp in this file generated by your build process to make sure the file gets updated. And when this application cache file gets updated, the browser will download all the files you listed under cache. All right. What does that actually mean? That means you will have now an installation process of your web application. So you see that, and that's from our application. The name is hidden here. And the user is informed that there is a newer version of this application available, and we are updating this version. And the application cache will provide you with events so you can react to this information. So the spinner is not mandatory, it's done by us. So you could show a progress bar there, you can show the user that it's downloading, you can even know when the application cache update failed for whatever reason. All of that you will be informed for. Two things I would like to mention which make working with application cache pretty hard. One is it's an additional cache. So some people, when they have static resources, will say, okay, this application cache file doesn't change that often. Let's set a max age forever. So make sure the HTTP cache caches this file forever, and then I use cache busting if it changes. The problem is the file which embeds the manifest file is always automatically cached by application cache. So what happens if the browser goes to your page, www.mypage.com, it will surf the index.html, will try to check the newer version by checking with the manifest file. The manifest file is cached forever. So it will say, oh, so the application didn't change. So you will be never ever able to update your application. You really have to call all your users and say, well, delete your application cache file, I want to deploy a new version. So be aware of the additional cache. The other thing is, as I said, the file embedding the app cache manifest is automatically cached. This can be pretty tricky when you have multi-page application, like news sites or stuff like that. Because then all of these pages of a news site are automatically in the application cache, and this gets bigger and bigger and bigger. And if something gets bigger, the browser is more likely to kill that, because I said you have more guarantees than with HTTP cache, but in the end, you don't have a strict guarantee that the browser will say, well, I need more space, I delete that 50 megabyte page now. And there are a couple of other things which makes application cache hard to work with, especially for multi-page applications. And there is this beautiful article called "Application Cache is a Douchebag" by Jake Archibald. This is actually a very good resource, and I would highly recommend reading it before you do anything with application cache. So, is there hope? Because it seems like there are some sharp edges here. Maybe. There is a new specification called service workers, and it's actually available since Chrome 42, and it's working with Firefox nightlies. Microsoft and Apple haven't committed to it, so we don't know. But I give you a short idea what it is. So it is a programmable cache. It's the term service worker hints that it's a web worker. So it's something like a web worker with a specific purpose, cross-tab. And it's like a proxy sitting between your application and the network. So you can basically inspect the network connectivity going out of your app into the network, and like program caches, remember data, redirect, whatever you want. So if you are planning to build something in the future, maybe in the far future, or you just need to build something for Chrome starting today, have a look at the service worker. There are very good talks available, a very funny one from Jake Archibald at Google I/O, I think from 2014. So really good.
No? Okay, sorry. Yeah, the second thing, of course, is how do you get your data available offline once you have your application offline? So if you remember the Morrison example, our colleague from the UK, Rob Miles, told us that for them, a really breakthrough was when they thought of their updates in terms of commands. So for them, it was, okay, we need to update this product. So we have a method that says update product, gets the product and a quantity. So in order for them, they built a really simple JavaScript message queue and a message processor, and that's where those commands got stored. So, but what happens when their users, when the sales manager or whoever does those updates walks through the store and the tablet loses power? Then of course you want to persist that data, that message queue. And for them, they used web storage. Web storage, there's actually two versions of that. There's local storage and session storage, and it's a pretty simple key value store with a synchronous API. So for them, that was enough to persist their commands in the queue. The second project, the traveling product tester, we actually started off with web storage, but we're now using IndexedDB, and that has basically three reasons. The first one is pretty obvious reason. We just, web storage comes for Chrome at least with 10 MB, and that wasn't enough for us. So we actually could not identify those distinct commands that Morrison was able to do. For us, it was only the document changed. So we had huge blobs of JSON that represented those documents that we needed to store. And so first reason, 10 MBs wasn't enough for that. And also, yeah, as I said, we couldn't distinguish those commands. So for us, we implemented that autosave mechanism that saved those documents every 5 seconds. So for us, the only information that we had about our data was it changed. We didn't know what exactly changed. So the second reason is also that we wanted to place queries on our documents. So we wanted to ask like how many of those specifications and quality analysis belongs to one product. And the third one, that was maybe the most important one, that our users used to use our application, and they usually opened it in multiple tabs. So now we had those syncing mechanisms in each tab. So our single-threaded JavaScript got suddenly multi-threaded, and that messed up our data when we used web storage. So that's the third reason why we needed IndexedDB, so that we have locking transactions, so that when the sync mechanism got triggered, that not all the tabs like mess up all the data at the same time. So IndexedDB offers those locking transactions. Now we can have a brief look at the API of IndexedDB. And yeah, as you can see, first line, it's pretty easy. You call indexedb.open, you give it a name and the version you want it to be in. So that also means the name is the unique identifier for the IndexedDB. So that means you can have multiple IndexedDBs for your application if you want to. And another interesting thing maybe is that IndexedDB is event-based, so you're not getting back, when you call this, you're not getting back your database, you're actually getting back the event you can listen on, the on-success event. If you want to place transactions on your IndexedDB, it's also pretty simple. The transactions, you give it object stores you want to operate on and the kind of transactions you want to do. It basically offers only two types of transactions, read-only and read-write, and you request the store by passing in the store name. You can place a request, and as I said, event-based, so you listen on the on-success event in order to get your data. And as most of you probably guessed, IndexedDB has indexes, indices, so you can also query on indexes and get a cursor, request a cursor on that, and it works the same. So you just listen on the on-success event. So that is how the IndexedDB, like a brief look at the API. So another thing that is maybe interesting and maybe something like we try to like not phase in the very beginning of the project is migrations. Because what you have now when you use IndexedDB on every client, of course, they have their own database. And of course, we're having a central data store, which we have a MongoDB and a Java backend. So maybe one interesting point is, a bit a side note, we wanted to reuse that kind of business logic for the migrations. So when we wanted to do migrations, is to clean up our data, rename some fields, drop some fields, we wanted to share that piece of business logic between our central data store and our Java backend, and also in the front end with the IndexedDB and the JavaScript client. So for that, we used Nashorn. You maybe know it. It's the re-implementation of Rhino, and that's a Java engine that lets you execute JavaScript. So that's how we shared that piece of business logic. So once you want to do a migration, we start a Spring context that goes through all the data in the MongoDB and migrates them. And once the clients start sending requests, they get an upgrade needed and know that there's a newer version of our application available. And as Johannes explained, how we deliver our application to the clients, with that application, also our migrations JavaScript file gets shipped to all the clients, and they migrate on the IndexedDB then as well. Yeah, last but not least, the fourth HTML5 storage technology we're going to talk about today is File API and File System API. As I mentioned in the beginning, our users go usually to the factories and take pictures of the products they see there to quality check them, and that's how we deal with the pictures. So when the user wants to upload an image, we know that's not really uploading, especially not when they're offline, but that's what the button says. We actually store the file locally, and then we update the image source. And the image source looks kind of like this: file system .http:// and then the domain, because that's how File API distinguishes between the different applications that may use File API, /persistent, and then / the image name. And then once the user is online, we upload the file to the server. And actually, to get the image, we do the same steps, just in reverse. So we download it from the server, store the file locally, and then update the image source. And now, one interesting thing that I didn't tell you so far is that we actually live in a very fairy tale world with our project, because we only have to support Chrome. We're building an internal application, and our client said it's fine to only use Chrome. So what you can see here, like we have shamelessly stolen from a site that said caniuse.com, which is pretty handy. It shows you for the different libraries if they're compatible with the browsers. So this is for the file API, and it looks all fine. That it gets supported by the common browsers. But if we have a look at the file system API, which actually physically stores the file on your system, it doesn't look so good anymore. So this is only supported by Chrome, and so as far as I know, it will not be supported by any other browsers than Chrome. So if you have to deal with images and offline functionality, that's something you may want to check twice. Maybe that's something you cannot offer your users, or like we heard that you can store blobs in the IndexedDB. That might work for the images for you, but we've no experience with that. So just a word of caution. And maybe also one thing, the IndexedDB is designed by committee. That's something you can notice when developing with IndexedDB. If you want to place multiple requests in one transaction, that's kind of hacky to do. You have to do that. You have to place one transaction in the unsuccess event of the other transaction. So that's kind of a hacky thing that we just recently faced. So you might want to be a bit more careful with that. And also, we found Mozilla's documentation of IndexedDB way more useful than the official one. So, but yeah, just so you know. And now Johannes tells you something about the data changes.
Yeah. So I said in the beginning, doing offline application is nothing new. So when it comes to data synchronization, there are patterns out there you can use. And the two most common ones are the command pattern and the memento pattern. Both of them are in the Gang of 4 book. They are more featured for undo redo, but you can also use them to do synchronization. And if you can, always go for the command pattern, because it's pretty simple. Let's look at the order pad example. So someone updates some order in his system, and then there comes an OK button. And with this OK button, there is a new view. So this OK button and the new view indicates that the user has issued something discrete, a command. He said, please update my order. And this command you can form into an object, which can be transformed into JSON. And then you store them in a queue to be processed on the server. And once the internet becomes available, you send it to the server, and the server can either process the command or store the command, and you will do event sourcing, whatever fits your business need. This is the more easier way, especially when it comes to handling conflicts. Because if there are two commands which don't fit to each other, you can say to the user, look, we did this update, and with this update, there was something wrong. A colleague also updated this resource. So the user has a concrete point you can point him to. What did change? A little bit like a Git commit, right? You can say, with this commit, we have a merge conflict. But what if we have an autosave button? As we said, our users describe how products work against the specification. These are documents, and they're printed out as PDFs. So our changes look rather like this. You can think which is the newer version. These changes are really hard to show to the user, right? But how does it work? So every 5 seconds, we will take the state of the document from the database. So while the user types, it will automatically be entered in the IndexedDB, and then we take a snapshot of that and send it to the server, if there is a server available. If not, we just skip that this action. And then we do it again, every 5 seconds. And this by this way, of course, the changes of the user come to the database, but you don't have an idea what actually changed in the document, because showing a diff of a JSON to your user, if he's not very technical, doesn't help him. And that's why conflict resolution is a bit harder, because, I mean, technically detecting the conflict is not an issue, right? But like, how do you solve that from a UI perspective? Luckily, we were able to use a shortcut, because our client told us, well, you know, most of the time there's only one person in a factory and doing the checks, so don't worry about conflicts too much. And so they basically get the older version or their version and the one which is stored, and then they can copy and paste stuff between the versions. Something we might have to improve soon.
So, yeah, what is it now? Is it a developer's nightmare or a nice little challenge to solve to build an offline web application? And as you realized during the talk, for both applications, it looked quite different what offline was and what technology they used. So it's the same that we heard in the keynote today. There's no silver bullet. So also for building an offline web application, we don't have the recipe, cookbook recipe for you so that you can just build your offline web application. But we can share some questions that we asked ourselves to decide what kind of technologies work for our projects. So first of all, the size of the data. As I mentioned, for the Morrison, the supermarket chain, for them it was totally sufficient to use web storage, which is easy to use. There's not much you can that's really easy to use. It has a really simple API, and for them this was enough to persist their queue data. But yeah, for us we needed to use IndexedDB, or we wanted to use IndexedDB, but that of course introduced some more complexity. It's also not only the size but also the structure of the data. We were also lucky. We didn't have much dependencies on our data. There were not many relations. So if you have to have many relations in your data, that might also not be the best choice. Something you also should think of is kind of using the same technology for your local, for your central storage, and also for your storage on the client side. So for us, MongoDB and IndexedDB were quite fine, but if you have to run a SQL database, you may want to rethink what you're using on the client as well. Also, one thing we didn't talk about in this talk is sensitive data. Yeah, we were building an internal application, and it's only running on our client's intranet, so we didn't have to think about sensitive data, or that's got kind of outscoped. But yeah, with all those HTML5 technologies, you have to be aware that everything on your user's machine is on clear text. So if you're dealing with sensitive data, you may want to encrypt it. And also that might be tricky because encryption in JavaScript is hard and maybe not that secure. So if you're really having sensitive data, that's maybe something you cannot bring offline or find a different solution. Yeah, as Johannes mentioned before, the potential for data conflicts. We are at the level where we could offer our users, as Johannes mentioned, a diff view and all the fancy stuff that maybe Git gives us, but that's something that turns the project from a 3 months prototype project to a 3 years project if you really want to have a sophisticated conflict resolutions. So for us, it was sufficient enough to just say, oh, another colleague added the same data that you did, you can revert your data or save a copy of your data to then manually merge that in. But we did not have an auto-serve resolve mechanism. And also the Morrison, they introduced pessimistic locking. So they just locked the data once someone was walking through the store, because that was how they, how the people used this this application. So there was only one person supposed to update all this product data. So there was no need that this needed to really work collaboratively. And then one thing, yeah, of course, browser support. As I mentioned with the file system API, we were lucky. It only had to work in Chrome. If you need to support Internet Explorer or, I don't know, horror, then you also maybe need to think of something else. And that one is pretty obvious, but also worth thinking of, the amount of functionality you want to work offline. Both the applications we had did not work fully offline. So there were simply some functionalities that we just did not offer offline, and that was perfectly fine for our customers. But that's something you really maybe need to push for if you're building a project, to identify the core functionalities that you want to build offline. And yeah, Johannes is taking over now.
Yeah. So to summarize, what is our experience, what is our learnings out of that? And the first one is definitely make sure you challenge the requirements the clients are asking you of. You can see that quite nicely in this little comic. Yeah, so 5 years or a few hours. And that's quite true if you're developing offline web applications as well. You get into all crazy problems if if you want to really work the full application offline. Like if you're building the website for a new site and the business comes and say, yeah, the user should always be able to search for all articles. Well, mobile devices are not that big. And probably they don't want to, right? For us, it was the same. So our application consists of a lot of steps in the workflow to get a physical product out in the market. And the very first one is to specify what kind of stuff I want to have. How should my socks look like? And this includes a library where you can pull the information about the fabric down. And all of that does not have to work offline because they're sitting in their office with good internet connection, although sometimes it doesn't work, but that's a different story. And you don't need to make that offline. You don't need to pull the whole library offline, especially not all the images in the library, because this would simply be too much space, even on a Chrome desktop, because it's also limited to a certain amount. Other stuff is how fast do the data need to be available. So do you need to make sure that certain data are synchronized first? Unfortunately for us, because the system is only documentary and not legally binding, we don't have an order that the images should always be synchronized last or first or whatever. So there's a lot of things. If you really ask your client, what do you really need? What should you really invest our time in? And then you can build something within a reasonable time that satisfies your customer. Yeah. And the other thing is, if you know you will have to support offline, start with offline. Because the people at Morrison's kind of, shifted the offline story to the back of their backlog. And they said, well, maybe we never need that. And then they found out they needed it, and they didn't have a command pattern architecture. And as you know, architecture is the stuff that's hard to change. And shortly before you want to go live, to change from a request response base to a command pattern, that's quite a bit. So think about it offline, and if you know you're going to need offline, better do it from the start. Don't do it if you don't know if you will have to do it, because then you might waste money. But if you know, do it from the start. And finally, I would advise you to explore the possibilities. We have talked about 4, if you consider service worker 5 web storages, and we use all 4 we talked about in our application currently. So we said IndexedDB is for our data, application cache is to store the application itself, while the file system API is for storing images. But also we have a feature which is quite interesting, where we use local storage for, and it's actually not for offline. Steffi said our users want to use the application multi-tabbed. So they might have one tab or one window open of an older version of the socks they're going to build and a newer version. And they want to use copy and paste between those 2 tabs. And copy and paste, if you use the native one in the browser, is HTML based, and that's not really what you want. So what we did is we offered a copy button, so you can press copy, and the copy button will write that into the local storage, and then the other tab can just read it. So you can use that to build copy and paste. And also there is an SQL database available in most browsers, but it's deprecated. So it's called WebSQL. I don't know if they will ever remove it, but yeah, you shouldn't use it, is the statement. All right, I think we are up for questions now.
Probably I missed that part. You were explaining that this file with cache declaration is also cached, and you have to be careful about that. So what you should do to avoid this? So what are the problems, and how you can bypass these problems?
So it is cached to the standards of the HTTP headers, right? So if you set the HTTP header no cache, and you have no evil administrator with a proxy in between to cache that, then it should not be cached. So set no cache. So I think we set always no cache for everything, because we just want the application cache to cache the stuff, and then you're safe, reasonably.
There's someone with a...
Yeah, the files, where exactly are they stored? Are they stored under a profile cache, or can they be stored anywhere?
That depends on what, like our JSON, or
no? You said that the cache is
the images.
Yes. Can it access any place on your hard disk, or is it only under the profile of the browser? Is it browser local, or is it? So does it mean that your application have access to your whole hard drive?
No.
No, definitely not. So you have a local file system in the browser, and you only see that. You can go if you use Internet Explorer or Windows Explorer, right? Windows Explorer or Finder on a Mac, you can access the images because they are literally stored in files, but you can't access anything on the disks, because that would be a security. Yeah.
But it's persistent storage. Okay.
Test the offline.
How did you test the offline mode? Did you pull the internet cable out of the socket, or?
No, we just didn't start our backend. That's like how we, as developers.
We don't use my.
Oh. Sorry. Yeah, I gave it to another one with a question. So we just, for us, if you test it locally for the developers, we just like stop running our backend, and then it's like kind of not having connection. But of course, we have a QA, like a quality analyst in our team, and she just like switches off her internet and then tests the application before we deploy.
By the way, there is this property called navigator.online, which you can query from your browser. This only tells you if you're connected to any network. So it's not really sufficient to tell when you're offline, because being connected to a Wi-Fi has no connection to the internet, and navigator.online will be true. So it gives you an idea if the Wi-Fi is turned on, but not enough for actually implementing something. That's why we always ping our server to check if the server is available, because functionality-wise, it doesn't matter if we are offline or our server is down, right?
I have question. sorry. One more question about this APP cache, and you rely on that to store your application resources like scripts and like pages. So did you have an issue with that? So this cache was cleared. Like you have one resource missing from that. Like you're offline, and just browser deletes that because I don't know, he does not guarantee the cache integrity or whatever. Like,
The browser guarantees you that it either deletes nothing or everything. That's the guarantee of the app cache.
okay, and one more question. Do you have in your system, in your web application, do you have a lot of places where you check if you're connected? Like how did you do this? I mean, do you have a lot of code that checks if I'm offline, then do this? Or?
No, we are using Angular, and there's one connectivity interceptor, and he knows. On a high level, yes. It's a bit more complex because the details, especially because we don't want to synchronize on multiple texts at the same time. But yes, in principle, yes.
I have a question. How do you care about that your application won't break the offline mode? I mean, do you have any special regression testing? Or I have a situation when application was meant to work offline, but after some updates, it stopped. So do you have any special recipe for that?
No. Do you have any?
We tried a little bit with, so we have this connectivity interceptor, and of course you can tell that connectivity interceptor you're offline now. But that's not really testing the offline mode, but that's as far as we can get. So we basically tell the application now you're offline, and then it behaves offline.
I have a question. Have you tried any libraries for automatic synchronization between your MongoDB database and IndexedDB on the client side?
No.
Yeah.
Because I know there are some tools, libraries for doing that. Do you have any, have you thought about it?
Isn't like Hootie something doing something like that? Yeah, and I think the problem with Hootie, for example, is that we have to use Java in the backend, and that doesn't work anymore. But I've never used Hootie, so I don't know. That's as far as my knowledge goes.
Yeah. So if you use Hootie or just PouchDB, the sync mechanism, when you use a CouchDB as a backend, it's supposed to work pretty well, but because of business constraint, we were using Mongo and Java, and then you can't use something which requires Couch.
Yeah, and the Java requirement came from the client, and sometimes you need to go with what the client says.
And about the IndexedDB API, kind of, did you consider a higher level library built on top, or you just like started with it and just kept it? Because it's kind of not just save my document, but open transaction, then like get a cursor, or it seems like complicated stuff.
Yes, it's complicated. Yeah, we did not start off with IndexedDB, but actually, I don't know. Is there?
We looked a little bit. We found one interesting Angular one, but unfortunately, this one was throwing alerts when there was an error, which was not feasible. So we looked a little bit around. To be honest, we started that project more than a year ago. So maybe there are some out there now, but. Yeah, and as you can think, we have, of course, we have a wrapper around it. So we, like, on a day-to-day basis, we don't talk with that API, but this is the API provided.
Yeah, also for mocking IndexedDB is not really nice, just in case, yeah, for testing. Sorry, he's waiting longer, sorry.
Did you have any strong security requirements, for example, because I imagine that the session never expires, and I wonder if you have some requirements about the authentication, authorization, etc., these security problems. And
No, that's a very simple answer. No, we don't have that.
okay.
If I understood properly, you use something like Memento pattern. So you store locally all the changes, and then when you get online, then you flush the changes to the server. Is it what do you mean? And the question is, if during the time when the application was offline, if there were like 5 changes on the same objects, and actually only the last one is needed because all of them were related to the same entity, do you somehow optimize it? Do you have some pattern for finding these redundant changes, or just you flush them as they are?
Yeah, we actually have how we manage our queue is a bit more sophisticated than what we were able to show now. So we would not have the case that if a document got added multiple times that we would just like push everything in the queue and then we just would take the last one in. So it's not that we have like a stack of changes and that we only needed the last one. So that's a bit, yeah, I don't know. Do you have more about how our queue
So
logic
basically, we sync always just the latest version, because there is no user connection to the changes. It's just this 5 seconds interval. We just synchronize the latest changes, and that's it.
Did that help or? Okay, good. No more questions?
Okay, thanks very much for attending.